It is the homework about the one sample t-test. It is the homework is one sample t-test. So we have to apply the 5 steps. So here is the hypothesis. That is step number 1. Then I can say that is the left tail. And we had S, the sample standard deviation. So we have to apply the t-test because we don't know how much is the sigma. And the second step, we need the test statistic, the t-score. And the formula was take the sample mean minus the initial setting value over S over square root of n. So here is the statistics. So let me plug the 20 for the sample mean minus the initial setting value was 24. And the sample standard deviation S was 5. And square root of the sample size is 15. So let me take the test statistic. It will be negative 3.098. Okay, so now we have the t distribution. It looks like the standard normal distribution with the mean 0, and the test statistic is a negative. You know, when we have a less than statement in alternative hypothesis, that means when we have a left tail, most of the time we have a negative test statistic. So here's a negative 3.098. Then now we need the critical value because in the t-test we apply the critical value approach. So you know, it is a left tail, so the test statistic is a negative, and also we need the negative, the critical value. So we have to go to the t-table to get the negative test statistic. But before, we have to know how much is the alpha and what is the degree of freedom. And absolutely the degree of freedom is n minus 1. So the sample size is 15 minus 1. So the degree of freedom will be 14. And the alpha was given here is 1%. It's a 0.01. So when I go to the t-table, we have to remember is what is the alpha and how many is the degree of freedom. It's a 14. It's a 0.01 and 14. So let me go to the t-table. So at the top there is the probability is a 0.01 and 14. So the critical value will be 2.624. But let me make the t-distribution again. It's a mean equals 0. You know, actually, we need the t-score is here as a critical value. And we can expect that is a negative 1. And there is the probability 0.01. That is alpha because we had left tail alternative hypothesis, right? But please look at this. That is a positive because the t-table gave us the t-score here with the probability, the upper tail probability is the same as 0.01. So the probabilities here, right? They are all is right-tailed, right? But it's not only the standard normal distribution, but also the t-distribution is symmetrical. So I can say the positive t-score is a 2.624 with the upper tail probability and the degree of freedom. But we knew it's a symmetrical. So the left tail, the critical value, it would be same as 2.624, but it must be negative. So let me go back. The critical value will be negative 2.624. Okay, so the critical value is a negative 2.624. That is a critical value. and this one was the test statistic. And now the test statistic in the right tail, right? The test statistic is in the right tail. Then we can reject the null hypothesis. That is another decision rule using the critical values. Then we can make the decision will be, just a second. The critical value is a step 3 and decision step 4. And now we can make the conclusion. We have to make the conclusion based on the alternative hypothesis. The alternative hypothesis was the mean is less than 4. I'm sorry, it's less than 24. Then we rejected the null statement. Then now the alternative hypothesis is true. So I have to make the conclusions positively. So I have to say the data provide the alternative hypothesis. So can you make the conclusion? So at the beginning, we stated it's a left-tailed, and step number 2, we take the negative test statistic, and also in step number 3, we take the negative critical value from the t-table, and we made a decision, and we made the conclusion for the alternative hypothesis. So now it is one sample t-test. Okay, so let me go to the it's a number 2. It's a number 2. See, step number 1, right tail. It is a right tail. The right tail means, yeah, it's a to the right. So I can expect it's a positive test statistic and positive the critical value. So same way, you can take the test statistic. I mean the 28 minus 27 over 7 over square root of 32. Then the test statistic will be positive 0.81. So test statistic will be positive 0.81. And now we can take the positive test statistic. Now the alpha is a 10% and the degree of freedom will be 31. So let me go to the t-table. 10%, 10%, 10%, 10%, and 31. I can take the critical value positive 1.309. So let me go back. The test statistic will be positive 1.309. That means it was the test statistic and the critical value, that is the positive 1.309. Now I can say the test statistic is not in the right tail. It's not in the right tail. So decision will be do not reject the null hypothesis. And I told you we can make the conclusion is based on alternative hypothesis, which was is greater than, the mean is greater than 27. But now we do not reject the null hypothesis because the test statistic is not in the right tail. So we have to make the conclusion based on the null statement, which said it is 27. So it's actually it is not greater than 27. So I have the conclusion is negatively. That means the data do not provide sufficient evidence to the alternative hypothesis. Okay, so because we do not reject the null hypothesis. So the second example, it is right tail. then we can expect the positive test statistic, positive critical value. When I comparing the test statistic and the critical value, the decision is fail to reject the null hypothesis, then we do not support the alternative hypothesis. So do you have an idea? So let me keep going. Let me try the number 3. Number 3 here, it is a two-tailed. The two-tails means on the t-distribution, before, when we took the p-value in the z-test, we take either one, then twice, because the p-value is not only the right tail, but also the left tail. But the standard normal distribution was symmetrical as well. So we just take the either probability and just take the twice. But now, the other way, the alpha was 5%. Then now we can split half of here and the other half of there. Yeah, it is the same function as we did the twice, but now it's a split. So that is a 0.025 and 0.025. So now we can take the test statistic. By the way, the test statistic is a negative is 0.81. And the critical value, again, that must be plus and minus. The plus and minus, I mean the -1 here and +1 there, because it is a two-tailed. And the degree of freedom is a 31 again. So let me go to the t-table, and I have to look for the probability 0.025. It's not 5% because already we split it, and the degree of freedom is a 31. So let me go to the t-table. We split the alpha from 5%. That is a 0.025. 0.025, and the degree of freedom is a 31. So the test statistic will be plus and minus 2.040. So let me go back. Now the critical value will be plus and minus 2.040. So here is a negative 2.040. There is a positive 2.040. And now the test statistic was here, negative is a 0.81. The test statistic is not in the right tail. It's not in the, not in the left tail. It's not in the right tail either. So what will be the decision? Fail to reject the null hypothesis again. So we do not reject the null hypothesis. And now we make the conclusion for the alternative hypothesis, which is said the mean is not equal to 23. And now do not reject the null hypothesis. So we have to accept the null hypothesis. Then we have to make the conclusions negatively for the alternative hypothesis. So the data do not support the alternative hypothesis because we did not reject the null hypothesis. So look at this. When we have two-tailed, then we can split the alpha is onto the two-tailed, but the right-tailed just go to the right tail. Left tail, it just go to the left tail. So we have three kinds of the testing procedures: the left one, right one, and the two-tailed. So case by case, we can take the probability and the degree of freedom n-1. Then we can take the critical values. Do you have an idea? And now let me go to number 4. As a number 4 is a one more step to state the step number 1, the hypothesis, right? But always the null one is equal to something, but in alternative hypothesis we have to choose is one of them. So when you read the problem is carefully, the study reported before the average the watching TVs per day is a 3.91 hours. And now we have a 15 people, the 15 sample. And now it is a sample mean from the sample. It's a 3.36. It's not 3.91. And probably we can compare them together. But it is the X bar, that means it's a sample mean. Then the 3.91 must be the population mean. The notation sample mean is X bar, and the population mean is the mu. So now the mu, that is the population mean. And let me put the same population mean in alternative hypothesis, and we have to choose one of the inequalities, but here is the key, it's a differ from. Then what will be the alternative hypothesis? It's a not equal to. So actually it is the two-tailed, and the alpha was 5%. So now we can expect, we can split on the t-distribution. Here is half of that, 0.025, and the right tail is a 0.025. So we split, it's a half and half, it's onto the at the end tailed, split the alpha, and the degree of freedom, will be 15, is minus 1, is a 14. So when you go to the t-table, where is the t-table? Yes, now here's the t-table. So we have to look at the 0.05, 0.05, because it's a half and half, and 14. So the critical value will be 2.145. Okay, so the critical value will be okay. It must be plus and minus. That is a two-tailed. It's a plus and minus. What did I say? I forgot. Yeah, you take the critical value from the t-table with a probability 0.025, and the degree of freedom is a 14. But remember, the critical value is a minus t-score and positive t-score. And step number 2, you take the test statistic. If the test statistic in the middle, they are not in the end tailed, then do not reject the null hypothesis. But the test statistic here or there in the end tails, then we can reject the null hypothesis. So it depends on the alpha, depends on the critical value and the test statistic. You can make the decision and you can make the conclusion for the alternative hypothesis, okay? And this one is a two-tailed, is because of the keyword, it's differed from. Briefly, I can do this homework, yeah, but you can complete the homeworks. So where is the number 5? Yeah, here's a number 5. Yeah, again, in this case, you have to click the data. You have to click the data and the t-table to get the critical value. So now I have to say in the null, it's always is equal to what? Here is the initial population mean. It's a 43 degree, and here is a sample mean. So I have to plug the 43 here, and I have to choose is one of them, but see, it is a greater than. So I can expect that is a right tail. then I can expect there's a positive critical value. Yeah, it's a positive critical value from the right-tailed. And we just put alpha, it's all alpha in the right-tailed. And how many degree of freedom? Yeah, here's a 20. The degree of freedom will be 19. So go to the column with the probability 0.01 and the degree of freedom is 19, then you can take the critical value. And comparing the test statistic and the critical value, then you can make the decision. Only when the test statistic in the right tail, then we can reject the null hypothesis. Then finally, you can make the conclusion for the alternative statement, right? Yeah, it depends on the decision. So it is the right-tailed. Let me try the last question. Number 6 is might be the left one because in number 4 we tried the two-tailed and number 5 is right one. So I can expect it's number 6. It must be left-tailed. Let me check. Okay, not here. Sorry, just a second. Where is the number 6? Yes, here. Here's the number 6. Let me see. It's always is equal in the null. Equal to I think it is the sample size and the IBI. I don't know what is IBI. Yeah, here is the IBI. It's a 0.9. Where is the claim? Do the data provide sufficient evidence what? Decrease the ABI. You know, actually it is 0.9, right? But the sample ABI, sample mean, that is the lower than 0.9. So we want to test if it is a decrease. So we compare it to 0.9, it's a 0.9. As I expected, it's a decrease. It must be the left tail. So the test, I expect the test statistic is a negative, and the critical value is a negative is as well. Okay, so on the t-distribution, we have to take the negative t-score with the whole alpha is 1% again, but it must be is a negative. And the degree of freedom, is a 186 from 187. Let me look at the t-table. Yeah, here is a t-table, right? And the degree of freedom, is the 0.01. So here is a 0.01. Please look at the degree of freedoms. Yeah, we don't have exactly degree of freedom 186, but roughly we can take the closer one, right? So the 200 is the closer one to 186. Then we can take the t-score 2.345. But remember, it must be negative because we had left tail. So the critical value must be negative 2.345. And you can take the test statistic. If it is in the left tail, then we reject the null hypothesis. Okay? So it has the 6 problems. It has 6 problems for the t-test. So we have to apply the critical value approach. So you can take the critical value from the t-table, depends on the probability and the degree of freedom. So please try this homework and to understand what is the one sample t-test.